Welcome to another video on my Raspberry Pi running Raspbian Linux. Again with a webcam for the overview and a fischertechnik motor attached, streaming video and a program that hopefully will work. And last time I managed, well, not really managed, but last time I got info on the frequencies that this motor would work. Now if I run this program, then this LED, let me change the view of the camera a little bit. Now this LED will work and this LED will work. It works now already, but now just on power. When I start the program, both will start blinking. One problem is that with the hardware pulse modulation, the LED isn't burning any longer. Question is that indeed a problem with the LED, or is it with something else? The point is, of course, that this motor only will work when there is a potential difference. In other words, will the voltage on one, for example this connector, be different from this connector? And last time I checked, that was not the case. Anyway, let's start this program. So you see here some blinking. That will write. Yeah, the connection between this wire and this LED has been removed, so it is not influenced anymore, but the motor doesn't work either. Last time I also used the Maxima program to determine the exact frequency, and then I found out that for the frequency of 100 Hz I needed to go down to a timing of 1980, and that still doesn't work. So the question is, what does work? I think for now the focus should be to get this circuit working again, this circuit which is right here. So is it necessary to put a different LED in place? That just may work and it may not. So first thing to do is try to get that, and I can do that quite simply actually by just experimentally holding this LED against this LED. And that means that it doesn't do its thing, so probably there's something not quite alright. Let me remove it, put this in its place, making sure it is the right polarity. Nope. Here nothing either. So it goes back where it was. The question remains, so I need to find out why and how this works. Well, this LED from the transistor circuit is working, and yes, it was a very small wiring mistake. But something else I noticed as well. This video feed seems to have not 40 seconds or so, but really 4 to 5 minutes delay. So what is the benefit of this live feed, which isn't a live feed anymore then? I am not quite sure. First, I am going to try, let's just stop this for now. Alright. Then, with this code unchanged. There's a lot of delay here. Now there is, now you can see how I put in the wiring. And here I fix it, a little wiring problem. So now this works, and now here I am with the code again, which I am starting. And still the motor doesn't do anything. So I am going to assist it, hopefully. Well, it works. Well, on this live feed you see it work, not yet on the video feed, so I could wait, but considering the delay, not quite sure if that is wise. But now I can focus on this one. Is there any change? I doubt it, to be honest. Yes, it does work, but does it work on electricity? Or does it work on pulse width modulation? That is a very big question. And here on the feed, which isn't delayed feed, it's still not working. So the big question is, what is the use of it? Well, actually, the fun is that I noticed that the, as I mentioned before, or earlier in the previous video, that the bare eye blinking is much faster than this video suggests, let alone this video. Well, yeah, this is next to real time, and this really isn't. So what next? Well, what I want to do is stop this one for now. If it lets be stopped. Yeah, and this is causing massive delay. the whatever error that is. Okay, now it's stopped. What I will do, alright, I will comment this one out, see if there's any change. Start again, watching the live feed. And now it would be very nice if I turn this in such a way that it is visible on the camera. And you can see the interruption in the video feed while the propeller just keeps running. Is there any change in speed? No. Well, maybe there is. Now that's kind of interesting. Okay, let me observe this. And again, the frequency is different than what I see with the bare eye. So it's running quite fast now. Let me interrupt. And I have to wait for the interrupt. Alright, there we go. And now I am going to reverse this. So what is the difference? Without halting the motor. Alright. And then I have to admit, as such, there is no difference. Well, it should be. So what else can I do? Well, add a huge delay somewhere here, time sleep, and then see whatever happens then. Because I doubt that 1 second is enough to show. Even halting it would be an idea. So with this, how can I make sure that it actually works? Well, right now I don't. I make a 5 seconds timing here. Then I want it all 0. Can I do that? I can try. And then I need, of course, a time.sleep here as well. Will this indeed hold everything? I dare not say anymore. But let's just see whatever happens. Alright. There it goes. And you see it run very slowly, but that is deception of the camera. Same thing with this, very much deception of the camera. And it doesn't hold. No, I said that wrong. It doesn't. It doesn't stop. So how do I make it stop? That is a very good question indeed. Or does it mean that that it is really still voltage fed instead of pulse width? Another thing is, of course, back to mathematics. Because it is with 10 microseconds and 100 hertz. So how does that translate? Between 200 hertz and 100 hertz. That's a very nice question. I thought I had done that last time correctly, but if I want to have 0, what do I do? Just let it fade? Not really sure. Back to documentation then, because this clearly isn't working. And with live feed on a huge delay, so it's not live, not even a few seconds delay, just really minutes. Anyway, back to finding out, hopefully. Another way to make everything stop is, of course, to make an end to it. And making an end to it is here done by PWM cleanup, as also shown here. So stop pulse width modulation on a channel. PWM clear channel and shut down. But I think clear channel would already be something. So what I am going to do is, do I have a clear channel anyway? I am stopping. I'm not even stopping it. Oh, that is a nice one. So what happens if I say let's see, wait a second, copy, and I go right here. Not sure what this will do, but well, I am sure that it will clear the channel, but what effect will it have? That is a good one. And then making a time dot sleep of 2 seconds. So quit, clear channel. Yeah, right. Now save this and start again. Does this make sense? Does this make any difference? Is it better? Clear channel. Well, that is clear. The clear channel doesn't have any result, by which I have to unfortunately say that it apparently is not pulse width modulation that drives the motor at the moment. I'm not happy with that conclusion. Not happy at all. Well, another thing is that this is blinking much slower, which is of course because of the time. 5 seconds, 5 seconds, 5 seconds and 2 seconds, 17 seconds, so each 70 seconds you see it blink. Will this make any sense? Not quite sure actually. So I start doubting my own calculations now. It should work because pulse width modulation does work on this motor, just not yet on the Raspberry Pi. So how to continue? New calculations. That's what I need. So I have to deal with 100 Hz and 200 Hz and everything in between according to the documentation. I'm also dealing with 10 microseconds. Yes. So I can actually stop this program. And what will happen if I just hold this? Let's see how fast this propeller holds. Okay, that's a few seconds, not so much minutes. Right, happy to see that. So will it start again on its own? And then I will have to conclude the answer is no, it won't. Alright. Definitely back to calculating. I did some reprogramming in the sense of getting info from the pulse width modulation and DMA channel. Here you can see the information I get. So this has just little changed. I am getting the channel info from the print channel command, which is just a function in the PWM API application programming interface, which it actually is. And what I notice is the subcycle time is 20,000 microseconds. Well, that means 20 milliseconds, which means 200. No, it is just 200 milliseconds. 20 milliseconds, and that is decimal 002. And with that decimal 00, that is a point. Is this no, that's not true, by the way. 20 milliseconds. This is 20 with cursor here is 20,000 micros. 20 milliseconds is 0.02, would be 200ths of a second. With a frequency of 100 Hertz, a period of 100, you get decimal 01. And pulse width increments are 10 microseconds. Well, then you get a which is of course much smaller. With this difference in subcycle time, which is twice as large as that frequency, and if you take 200 Hertz, you get of course a period time of decimal 02, which is exactly the same as 20,000 microseconds, if I'm correct. The question is, how do you cope with that? And I think I will just add 20 here. Yep, stopped. So if I just add 20 or 2, then I think this number should be lower, but let's see whatever happens. That's the second, and this is the third. Does it? Yeah, it crashes, so I have to say maybe 1970 is alright. So that is 1, 2, come on, 2, and the third. If it takes the third, it's alright. Yeah, it takes the third. So will this make the motor run? Well, let's just see whatever happens. Yeah, it will make it run. But does it run faster? Because this is certainly not going to work. This is not going to work, and this is not going to work, and I'm talking here and here. So how do I do that? I have to deal with a value between decimal 1 and 2, so in between a decimal 0.15. How do I do that? That is a very good question. And I would get somewhere, let's say 1975, and maybe 15 or so. Let's see how that works out. And that's the final thing I'm doing for this episode. Will this work anyway? I am unfortunately not noticing any change whatsoever. So is this motor really built, really suitable for this form of pulse width modulation on this on the Raspberry Pi? I have my doubts. I have sincere doubts by now. But then again, now that I know all this, and again with some calculations, I will try next time for the last time, I think, with the motor, and then see for something different. I haven't been able to find a nice cheap servo motor. I doubt if I'm going to order one. Anyway, that's it for now. Thank you for watching. If you like this video, please subscribe to my channel, YouTube channel. You can also follow me on Twitter and Instagram. Please be so kind to make a small donation, and you can find info on my website. Also on my website, my other projects. And this is to be continued. Bye bye.